what we're talking about are word problems. When we're applying these concepts to a real world situation, what we're doing is we're solving word problems. So that means if it's a system of equation application or a system of equation word problem, then we need to write two equations. So we'll have a system, right? And we need, for those two equations, to have the same two variables that would have the same values in both equations. Because that's what a system is, right? Before we had words attached to them, we knew that a system of equations was two equations that had the same variables. So that's what we're doing here. So we're going to start with number 5, because in general, kids get freaked out by fractions and percent symbols, and decimals for that matter. So we're going to start by writing two equations. And really what we're doing is we're translating these word problems into mathematical statements, right? So we're going from algebraic expression, from verbal or words to mathematical statements or equations. So we practice translating that. We have to look for our special words, is, equals, right? In addition to means to add, right? A percent of means we're going to be multiplying. Usually the word of means we're going to be multiplying. So that's the kind of stuff we're looking for. So we're going to start with number 5 because it's a little less intimidating with no percent symbols. So if you watch the video, you would see that the first thing we have to do on these things is we have to identify or define our variables. So that's what we call this, defining our variables, because in order for these to be systems of equations, the variables have to represent the same thing which numerically, right? So for number 5, that's when we're going to start with. So on your paper, you're going to write, well, I don't care what you write. You're just going to write the equation with me, because if you look back at the video, you can see the problem. So you don't have to write the word problem down. Everybody cool? So I need two equations. So I have this first sentence. The sum of two numbers is 36. I have another sentence. Their difference is 24. Find the numbers. And this is the answer, right? So we wouldn't normally have that. So this is what we're finding. So I'm going to show you how to find the two numbers are 30 and 6, right? So the first thing we have to do is we have to define our variables. So step 1, everybody's writing what I'm writing. Define the variables. And that just means tell what our x and y are going to represent. Right? So we're going to have two variables. We're going to have an x and we're going to have a y. And in this case, we're finding two numbers. So x is going to be, we're going to call it the first number. And y is going to be the second number. So now, if I say the sum of two numbers is 36, what is the word sum tell me I'm going to be doing in my equation?
Plus.
Plus, very good. It's the sum of two numbers. So what am I going to be adding in my equation? X and y. X is the first number, y is the second number. So x plus y, so the sum of two numbers is, so what am I going to put for is? No, what's equals, very good. Equals 36. So guess what I have? I have my first equation for my system. So now it says their difference is 24. There's less words, but if we know that there refers to the two numbers, it's like I said, Wasim and Omar have lacrosse practice today or whatever, and then I say there in the sentence after. Now I know that I was talking about Wasim and Omar, right? Does that make sense? I meant to say Sam, but I attached you two because you helped him so much, Wasim and Sam. And I'm not seeing him here today. Okay, so their difference is 24. So this is the easy part, right? So what am I going to put for is 24? Amara, are you writing what I'm writing, buddy? Doesn't look like you are. Get off my wall, remember? Face forward. Did you write the first equation? I'm going to come around and check. Did you write the first equation? Okay, so you ready for the second one?
Yeah.
Okay, what do you think we're write for is 24? Okay, so here, is 36 was equals 36. So what do you think is 24 is going to be? Equals 24, that's right. So my second equation, something equals 24, is 24. It's their difference. So their refers to the two numbers. So for the two numbers, we know that they are x and y, right? But what does difference tell us to do? Subtract. I heard somebody say it. So we're subtracting the two numbers. So now our second equation is x minus y equals 24. So first and second aren't important. It does not ask us to differentiate a first or a second. It just asks us to find the two numbers, and it was just a way to make it a little bit more specific. So you could have said x is one number, y is the other number. That would have been okay too. Does that make sense? So the first or second is not important, but to know that there are two numbers, two different numbers. All right, now we have a system. So we learned 3 ways to solve a system. By graphing, which is never the best way to do it, right? By substitution, which is not a bad way to do it if one of the equations is solved for x or y. Is one of these equations solved for x or y? That would mean, remember, that x or y are all by themselves on one side of the equal sign. But that's not the case here, right? So we could just add them maybe, or we could multiply one equation by a number and add them, or we could multiply both equations by a number and add them. But beauty of this one is, look what happens if I add them. What's y plus negative y? What's 1? Say it again. 0, right? 1 plus negative 1 is 0. 3 plus negative 3 is 0. So y plus negative y is 0. So now we have eliminated the y's by just adding them together. So x plus x is 2x. Plus or minus 0, so we don't write anything else there. And now we're adding 36 and 24, so that's going to be 60. So far, so good, Sam? Making more sense than you thought it was going to? Okay, so you got this one, you knew the answer to this one? Cool. So 2 times x equals 60, so now we're just solving for x. So now we know that one of the numbers is 30. So we know that x is 30. So how do we find the second number? How do we find the other number, Zanaya? Sorry? Yes, in either equation. So the value x, the value 30, we can plug in for x in either equation. And I'm going to use the one that does not have a subtraction or negative there. So I'm going to, instead of writing x in this first equation, I'm going to write 30. So now I know that 30 plus y equals 36. And now to solve for y, I subtract 30 from both sides, and y equals 6. So now I know that my second number, or my other number, is 6. So you'll notice, if you add 30 and 6 together, you get 36. If you take 30 and subtract 6, you get 24. That's the only way we can, a system is the only way we can solve a linear equation with two variables. Alright, so now let's look at the one that Omar asked about. Two sums of money are invested at 5% and 6.5%. The total investment is $10,000. I can't see the rest of that. And the total income is $552. So this one is obviously more intimidating. So we have to break it down a little bit more. I think I'm going to copy and paste that one by itself and put it on another page. Or actually, maybe I'll just do that. I think I can just paste again. All right, so now we're just going to ignore number 5, and I'll just cover it up with a box. That'd be great. But that's too big, so let's go down a little bit. Alrighty then. two sums of money are invested at 5% and 6.5%. The total investment is $10,000 and the total income is $552. How much is invested at each rate? So this is confusing in lots of ways. There's vocabulary in here that as high school students you may not be familiar with. Hopefully over the years in your math classes you've been talking about some of these things. And remember, this is the answer. So we're not supposed to know this yet because this was from the answer key. So the question is, how much is invested at each rate? Do you guys know what an investment is? It's money, right? An investment is money. So if I want to make an investment in a small business, I might loan them, well, I won't because I don't have $50,000, but somebody that has money may want to loan a small business $50,000, right? And then that small business will pay them back that $50,000 plus interest. Is that sounding familiar? Interest, right? So if you have money and you loan people money, then they pay you to use their money. Even though you're going to pay that money back, right? That's their product, right? They have money and you don't have money. They have money and you need money. They will loan you the money, but you have to pay them more than they give you, right? That's how we buy our cars. Most people, that's how we buy our houses. Most people, that's how people start businesses. Most people don't have $150,000 to $500,000 to buy a house, right? But the bank will loan us money so we can pay the builder or somebody else who owns the house that we want. We can pay them, say, $200,000 because the bank will loan us that money. They will give $200,000 to the person selling it or building it. Now we have to pay the bank back that money. We can't pay them back $200,000 though, because that wouldn't make any sense for the bank, right? The bank is allowing us to use their money for a fee, and that's what interest is. Does that make sense? So if I buy a house for $200,000, most of the time, this is going to blow your mind, most of the time you're going to pay back $400,000 or something crazy like that, right? We are going to use a simple interest formula, but they use a much more complicated formula. But for our purposes, we're not going to worry about the complicated part. We're just going to worry about what interest is. So interest is a percent that we either pay someone to borrow their money or they pay us to borrow our money, right? So if I loan Wasim $100 and say, okay, Wasim, you have to pay 10% interest on that, when Wasim pays me back, it's going to pay me $110. Does that make sense? So he's paying me $10 to borrow my $100. But then he has to give me all my 100 back plus 10 more. All right? That's how, so when kids want to know, how am I ever going to use this in the real world? Let me introduce you to today's lesson, right? Interest is something you need to know about. Almost everyone will borrow money at some point in their life. Even rich people very often borrow money because they can make more money loaning their money out than they have to pay other people. Anyway, a whole other thing. Okay, so does that make sense? So this question says two sums of money. That's a statement. The question is, how much is invested at each rate? So these two sums of money are invested at 5% and 6.5%. So there are two sums of money. So guess what our variables are going to be? X is going to be one sum of money. Y is going to be the other sum of money. So X is the money invested at 5%. But here's the thing. We're going to write an equation. We don't ever put these symbols in an equation. We've got to write the decimal version of 5%. So what's the decimal version of 5%? That's 50%, right? So you can take 5 and divide it by 100, or you can move the decimal place on the right back 2 places. So it's actually 0.05, right? If you do 5 divided by 100 on the calculator, it's going to give you 0.05. So if you're confused, that's what you do. Now this one really throws kids off. So let's rewrite that one as a decimal percent. Now we're going to take this and divide it by 100 on the calculator, and that would actually be 0.065. That's 6.5%. That's 5%. Does that make sense? The shortcut is just to move the decimal place 2 places to the left. A percent is basically a fraction, but the denominator is always 100, right? So 5% is 5 over 100. We divide 5 over 100 on the calculator, it's 0.05. So I'm reviewing something that you were supposed to probably learn in 5th and 6th grade, right? But still, we don't use it a lot, so it's good to review that. So our first sum of money, so this is our sum, let's write that, sum of, and we're going to use dollar to be money, sum of money invested at 0.05. Y is the sum of money invested at 0.065. Does that make sense, Wasim? Yeah. Okay. So now, how do you find interest, right? So there's a simple interest formula. So the interest is equal the principal times the rate times the time. For our purposes, our time is going to be 1. So our interest is just going to be the principal, and that's the money, times the rate, and that's as a decimal. So for our purposes, it's the interest is the money times the percent. But that percent is going to be written as a decimal. So, for instance, just so you can see what that means, and let you guys catch up, you do have to have some time to work on our review worksheet because we are going to test on that in a moment. So if I wanted to find the interest, if I wanted to pay, let's say, 5% interest on $200. Well, 5% interest on $200 is 200 times 0.05, or 0.05 times 200. Remember, it doesn't matter which way you do that. So on your calculator, you're going to just take 200 and multiply it by 0.05. I think it's 10, but I always double check my math when I'm standing in front of a bunch of people. Yeah, it's 10. So the interest, remember, is money too, right? So the interest is $10. So we have to understand how the interest works. So this is like our review of interest, and you should have been taught about simple interest also in 6th and 7th grade. And once again, this is truly a life lesson. This is truly something you need to know, the basics of this. Even though this formula for interest is not what you would normally pay, it's way more than that, but we won't get in that today. So now we've defined our variables. So we defined the variables, and that's what we have now. We know what x represents, and we know what y represents. So now we need 2 equations. So if I want to write, so now here's where we get to the other part of this. The total income. So we need to know that the income, remember, is the amount of interest you pay someone to borrow their money. So income is going to be our interest. So we have to know that they're the same thing in this problem. So interest and income are the same thing. That make sense, Sam? Interest and income are the same thing, right? If I were to loan Wasim $100 and he paid me back $110, he paid me $10 more than I gave him. That $10 interest is my income. All right? That's what I would earn on my money. So for our first equation, we're going to have x and y in it. It says the 2 sums of money, we define them with that first sentence. It says the total investment. Well, that means this sum of money plus this sum of money. Total means to add, right? So now I know I need to add x and y. Tavion, are you writing what I'm writing? Tavion, x and y equals $10,000. So that's the easy part, as long as you can decipher those 2 sentences. Does that part make sense, Tony? Total investment is the 2 sums of money, right? Now, total income is 552. So when we take a test on this, you're going to keep the total investment is not going to have the percent, so the decimals in it, right? They're just going to have the x's and the y's. The second equation's got to have this 0.05 and this 0.065 in it. So look, the 0.05 goes with the x. The 0.065 goes with the y. So the interest on x is just the 0.05 times x. Like the interest on $200 is the 0.05 times $200. So our second equation is going to start with 0.05 times x. See, we did almost all of our work for this second equation when we defined our variables. So that interest on the x money plus the interest on the y money, and the way we write the interest, we would find the interest on the y money is that decimal that represents 6.5%, 0.065 times y. Now we know the interest equals $552.50. So the income or interest, those are the same thing. Investment is how much money, the two different pots of money or two different sums of money, but we have to have the x's and y's in both sentences. So now we have a system of equations. So this is our system. So you define your variables, then you write your system. Now these do have decimals in them, so they're a little wonky, but that's okay. What we're going to do is we're going to use this strategy where we'll multiply this equation by either negative 0.05 or negative 0.065, because then when we add them together, we would have 0. So I'm going to multiply this one by negative 0.05. So when I do that, my new equation is negative 0.05x plus negative 0.05y, and I know you guys lots of times like to put the 0 before the decimal, and you can do that. It doesn't change the value of it. If you want to put a 0 before the decimal, you can do that. And this is an equal, it's not a subtraction. And now it's negative 0.05 times $10,000. And I think that's 50, but we're going to see. Oh, it's 500. Yeah, 10% of $10,000 would be 1,005. Anything. Okay, so it's negative $500. So that's our new equation. So we're going to bring the original second equation down here, and now we're going to add them together. So we multiplied the first equation by the negative one of these so we could get rid of one of our variables. That's the purpose of using a system, right? So now when we add them together, a negative and positive, the same number, when you add them together, you always get 0. So negative 0.05 plus 0.05, when you add them together, you get 0. So that's what we're doing. Now, negative 0.05 and 0.065, I think is 0.015, but like I said, when I'm doing math in front of people, I'm always going to double check myself with a calculator. Yep. So that's going to be equal to a positive 0.015. So I added those together. Now when I add these together, I'm going to get $52.50. Right? That was 50 in this equation. So when you add those together in your calculator, you get a positive 52.50. And do you see that I forgot my y here? So if you didn't write y, make sure you go back and add it in. So when you add those coefficients, don't forget your y like I just did. So now this is 0.015 times y. We have to undo the multiplying by dividing. And that leaves me y here, and then on my calculator I'm going to divide 52.5 divided by 0.015 equals $3,500. $3,500, but remember what Y represents. Y represents a sum of money, so that first sum of money is $3,500. So now I can do like Denai said, I can substitute $3,500, and this is the best one to substitute, the simplest one, right? That x plus y equals $10,000. So x plus y equals $10,000 is our first equation. That's the easiest one to substitute in. Now we know y is $3,500, so it's x plus 3,500 equals $10,000. So now to solve that one simple equation, I just subtract the 3,500 from both sides. And now I know that the sum of money at 5%, or our x, is $6,500. That makes sense, Wasim? That makes sense, Sam? That makes sense, Caleb Berry? That makes sense, Anaya? And I know it's a lot easier doing that with someone, right? But you gotta try it. The more you try it, the better you'll get at it. And I promise you, there are not any surprises. These aren't gonna be on the next test, but on the next test, they're gonna look just like these. Amari, go stick your gum out. What is that? Is it not gum? That's cool. That's just a little one. Okay. So pick your head up, Taj. Now we're going to go over, we're going to start working some problems on your review worksheet. If you'll notice, on your review, we had two other review worksheets. And on one of those, the first worksheet, I worked all of the odd problems in the video. And on the second worksheet, I worked all of the even problems in the video, right? So today, I'm going to work with some problems with you, and I'm going to let you pick which ones. And we'll just work problems until the end of the period. But you should be using all three worksheets to review for your test tomorrow. There's a review worksheet A, B, and now today's is C. All right, is this the right one? Okay. So this is where we're solving systems, but there are no word problems. Yay. There are 12 problems. How many problems do you think are going to be on the test? 12. How many problems do you think you're going to have to solve by graphing? 4. How many problems do you think you're going to have to solve by substitution? How many problems do you think you're going to have to solve by elimination? 4. Right? It's going to look exactly like the 3 worksheets you have, right? So is there a problem on any of the first 2 worksheets that you still are uncomfortable with? So is there a particular one you'd like me to work with you today? That's what I want to do today. And we're going to work your homework problems until the end of the class period. So there's no Caleb Davis. Caleb Davis. Please don't put your head down. All right. Is there anybody that would like me to work particular problems? 9? Okay. Oh, no. So you know how to do them all? You're comfortable with them? So get to work. Anybody else? Number 12? All right. Number 12. If you don't care to go over them with me, you want to work them on your own, great. More power to you. Go ahead and knock them out. I will post the answers actually to these are already posted, but I'll post them again on today's. They were posted on the review worksheet A or B, I think, or maybe both of them. But I'll go ahead and post them again here. Alright, Wesine, we've got the directions asked us to solve by elimination. So you are going to have to use the method that you want. Now, if you get on the test and you get stumped, and you can't remember how to solve it by elimination, but you know another way to do it, I'll give you partial credit for solving it correctly, even if you don't solve it the way you're asked to. Does that make sense? But elimination means we're going to add them together if we can. If I add -4 and 3 together, does that give a 0?
No.
What about -3 and +4? Does that give a 0? No. And there's actually not anything I can multiply just one of them by and then add them. So what this kind is we have to multiply them both by a number. You want one to be positive and one to be negative. So this is a negative and this is a positive. -4, +3. So when I see 3 and 4, I think of a product of 12, right? So if this were -12 and this were +12 and I add them together, I'd get 0 and I'd eliminate my x's, then I have an equation with only y's, right? So that's what I want to do. Here, I'm going to multiply this one by 3, because that would give me -12, right? 3 times -4 is -12. And I want to multiply this one by 4, because 4 times 3 gives me a +12, right? And then when I add those, now I get 0. So that's the whole idea, right? So 3 times -4 is -12x. Don't forget you multiply everything by that 3, so that's -9y. The most common mistake is to forget to multiply it by the 6 there, so don't forget that.
You have 4 to get
Say that again?
2x is positive. Can you multiply
Yeah,
them
so
by negative and stuff?
yes, very good. So if this were a positive, we'd multiply this by negative. Or one or the other. It wouldn't matter which one, right? You can multiply whichever one. Yes. So now we've multiplied the first equation by 3, we're going to multiply the second one by 4. So positive 12x plus 16y equals -32. Caleb Davis, you're supposed to be writing what I'm writing or working on your own. You're not supposed to have your head back down. Alright, now we're adding them together. And those equal 0 because I made it so, right? -9 plus 16y to +7y. 18 minus 32, or 18 plus -32 is -14. Please use your calculator. If I were taking a test, I would have checked my math on a calculator. Because I don't want to miss a problem because I had a moment, right? I want to make sure I'm checking all my work with the calculator. Now I divide both sides by 7. That's how we're solving that one-step equation. Y equals -2. So now I know I have one solution, and I know the y coordinate is -2. Right? How do I find the x coordinate now? Let's see.
Okay.
Yeah, and I can plug it into either one. So I'm going to plug it into the bottom one because I don't know. I just want to. Doesn't matter. You can do whichever one you want. So 3x plus 4 times -2 equals -8. So 3x minus 8 equals -8. Ooh, this is a good one because this tricks up kids a lot. But add 8 to both sides, that goes to 0. And this is not a blank spot. For some reason this freaks kids out. But -8 plus 8 is 0. 0 is a number. It's not a blank spot, right? Now this is 3 times x. I'm going to divide by 3. And it's also not x. Sometimes kids, I don't know, for whatever reason that is confusing to kids. So I'm telling you, that is 0. You have to put the 0 in there. 0 divided by any number is 0. And that's an x, not a y. Can't read my own handwriting. So our x coordinate is 0. You're welcome. Anybody else have one you want me to work? Caleb Berry?
Number
8. Alright, let's see, is that a substitution one? Alright, that's a good one. Alright, because it's got a fraction. We hate fractions. Substitution. So this one does, while it does have a fraction, so these are easy substitutions because they're both equations are solved for y, right? This one, not so terrible because we can just subtract 20 here. This one is a booger bear, right? Got a fraction in it. But at least minus 4 for y down here? Let's do that. This one's already solved. So we're going to use, instead of y in this equation, we're going to use negative x over 2 minus 4. Because they're the same thing. Remember how we put them in parentheses? So we're going to rewrite negative 3 times x minus, now this is a negative x over 2 minus 4 equals negative 6. So the y is here. Instead of the y, I wrote this expression. But this one, like I said, this one's a bigger bear because you got to remember negative times a negative is a positive. So that's plus x over 2 minus negative 4 is another positive 4 equals negative 6. That's an x. Are you with me so far, Caleb? All right. Shamar, I think I see your pencil moving. Good job. But Caleb Davis, you do not even have your pencil in your hand, so I'd like for you to sit up. So at this point, Caleb, there, I want to get rid of this fraction, but I think I'm going to go ahead and do this constant over here first. So let's get this over here first. So now we have negative 3x plus x over 2 equals negative 10. And I could just add these together, but then we have to worry about common denominators, blah, blah, blah. So let's not do that. Let's get rid of our fraction by multiplying by that denominator. Is this sounding familiar, Caleb? So 2 times negative 3x is negative 6x. And 2 times x over 2, so remember that's the same as 1, right? That's going to be 2 over 2, because that's a 1. 2 over 2, what's 2 over 2 equal, Caleb? 1. So that's 1x, so that's how we're going to get just x there. Equals, most common mistake, forgetting to multiply the 2 by this one as well. So that's negative 20. So far so good? So now I combine like terms, negative 6x plus a positive 1x is negative 5x equals negative 20. Divide both sides by negative 5. Now I know that my x coordinate is 4. I know I have one solution and the x coordinate is 4. How do I find the y coordinate, Caleb? Yeah, I can plug it into either one I want, and I'm going to plug it back into the one with, well, it doesn't really matter because this is going to be an easy one. I'm going to plug it back into here. So negative 3 times positive 4 minus y equals negative 6. So negative 12 minus y equals negative 6. Add 12 to both sides. And don't forget, now that's going to leave me a negative y. Negative y is not an isolated y. Now I divide both sides by negative 1. That's how we change the sign. And now we know y is negative 6. Make sense, Caleb? Taj, I need you to pick your head up, buddy. You're supposed to be writing what we're writing, Taj. What's that? You already answered it? Let me see. Number 8, you already did that one? Check it and see. Is that today's? Okay, but we're doing today's. So do you have today's done already? Today's is C. Worksheet C. That's B. Did you pick up today's worksheet, Taj? 7, yes. We're going to do number 7. Remember, if you ran out of, if I erase this and you need it, you can go back to the video. But I'm going to erase it because I want to do number 7 right below it here. So if you need it, go back to the video and it'll be there. All right. So number 7 is substitution as well, right, Jacob? So I can isolate this y easily or this x easily. I'm going to do the x. Let's subtract 2 from both sides. So now I know x equals 2y minus 2. Does that make sense, Jacob? So everywhere there's an x, I'm going to plug in, put your grouping symbols, 2y minus 2. But it has to be in the other equation this time, remember? So the x is here. So instead of x, I'm plugging 2x 2y minus 2. So negative 3 times 2y minus 2 equals y plus 20. So now I'm going to distribute. And get the y's on the same side. So now I have negative 7y plus 6 equals 20, right? Because that went to 0. Subtract 6 from both sides. Now I have subtract 6. I got to go up because I ran out of room. Now I have negative 7y equals 14. Divide both sides by negative 7, and y equals negative 2. So now I have one solution. The y coordinate is negative 2. What do I do to find the x coordinate, Jacob? Yeah, I can plug it in either one. Doesn't matter which one at this point. Here it matters, right? Once I do this, I can't plug 2y minus 2 into this equation. I have to plug it into the other equation. But once I have one of the coordinates, I can go back and substitute that anywhere. So that's what I'm going to do. So negative 2, I'm going to put it in this top one. So negative 3x equals negative 2 plus 20. So negative 3x equals 18. Solving that equation, x equals negative 6. And I have to write my answer as an ordered pair. So here's the thing, on the word problems, and we're not having these in the test tomorrow, but when you do the word problems with systems equations, you do not give your answers as ordered pairs in that case. Okay?